Hi everyone, let's solve this question. Find the magnitude of the y component of the electric field at point P shown in the figure. And of course the electric field is produced by one-dimensional rod that uniformly charged with lambda linear charge density 1 coulomb per meter. The length of the rod is A, which is given 1 meter, and the distance between point P with respect to the origin is x equal to 1 meter. So we have multiple choice A to E. Of course, one of them is correct. Okay, so the first thing you think about this question is a distribution of charge. So you have a rod. First step, you need to divide the rod into many small pieces, right? So the first piece is going to start at the very beginning, and the last piece would be at the very last piece of the rod. Let's show one of them, only one of them, for the sake of the solution. So let's say this point here, or this small piece here. Okay. Now that small piece will carry a small amount of charge. Let's call it dq. Okay. Because this is y-axis, I'm going to also say that the length of that small piece is also equal to dy. You will see in a second that this is very important. And this small piece that I chose is away from the origin by some distance. Let's call it y, because this is y-axis. Okay. And so the question asks for the y component of the electric field at point P. So first thing is, in order to find electric field at point P, let's assume there is a test charge, which is positive located at point P. If we assume the rod is positive, the electric field due to that small piece will be directed, radially this way. Let's call this one electric field dE, because this is produced by that small piece called dQ. Okay, I don't know what happened here. This is dE. Okay. Now, because this theta, the angle is given in the question as a hint, as a help, so we could simply say this angle is equal to this angle. Now, this component, this electric field has two components. One component will be to the x-axis. It's a dEx. We are not interested in this because the question only asks for the dEy. So it's obvious that dEy is equal to dE multiplied by sine of the angle. Okay. So let's write this. dE is equal to K. Remember, dE is a electric field produced at point P from that small piece here. Okay. So basically is equal to dQ divided by the distance between that dQ and the point P, which we don't have it here, but let's call it R, which equals to y squared plus x squared. Okay. And you see that this y keep changing, right? So if you take the next small points, to the left, to the left or right to the one that we selected, you see actually y change from all the way from 0 to A. So the y is variable, goes from 0 to A. And this is important. So it's equal to dk dq divided by r squared, basically y squared plus x squared. X here is a constant, just equal to 1 meter. Sine theta, in this case, is equal to y divided by r, which is y squared plus x squared. Okay. So let's do something about this dq. dq, we could define dq in terms of lambda. So here I could write the equation as k lambda. So again, dq is equal to lambda multiplied by the length of the piece, which is dy. So is equal to y dy. So this is lambda dy refers to dq. And then let's add these two terms here. So is equal to y squared plus x squared 3 divided by 2. Okay. Now the question asks for the electric field y component, so we need to do integration. Remember, this is dEy. Let's do integration for both sides. Now it's obvious the integration is in terms of dy, and we know that y starts from 0 and ends at a. Here I would like to tell you some common mistake, because this was actually a question of one of my quizzes. One common mistake was by few students, for example, assuming that theta simply is equal to a divided by x. This is wrong, because theta is not going all the way to point A, to the end of the rod. Okay, so that's one mistake. The other one was r, assuming r is equal to a squared plus x squared. That's also wrong, because r actually keep changing, right? R depends on where you locate or where you choose the small piece of the rod. So r keep changing, y keep changing, theta keep changing. So these are common mistake, and it's unfortunate when you do this mistake at the beginning, your integral will be wrong and everything else will be wrong. Okay, so the answer of this integral, the left-hand side simply is equal to ey. This integral is easy. I don't want to go through it, but let's just do it this way. Is equal to y squared plus x squared minus 3 divided by 2. You have y dy. You could multiply by 2 and divide by 2, right? So the answer in this case, you already know that this is the derivation of the term inside this. So the final answer simply is equal to k lambda minus 1 over square root of x squared plus y squared, and from 0 to a. So basically this gives you k lambda. Because you have a minus here, so I could just switch the terms. So once instead of y, you plug a and then plug 0. So the final answer will be something like this. 1 over, I'm going to just switch the 2 points. First I'm going to substitute 0. So it's a square root of x squared. That's right, x squared, since I put the x squared. So it's basically 1 over x minus 1 over x squared plus a squared. And this is the final answer. So if you plug the numbers in, you will see it looks like actually this one is the correct one. Okay? I hope my solution is clear, and it's very important to think about this common mistake. Okay, and people should, learn from it. Thank you for watching.